Can I have your attention, please? Right, so just to remind you, we have got these compounding periods annually, once a year, semi-annually, 2 times a year, quarterly, means the interest is covered 4 times a year, monthly, 12 times per year, and daily, 365 times per year. All right? Now, we've got a question here. It says, David invests 8,000 rand in a savings account which pays 8% per annum, compounded monthly. Calculate the value of his investment in 10 years' time. Okay? The interest here, so we have got 8,000. Okay. So we have got 8,000 rand. 8% per annum, compounded monthly. So the interest is calculated what? 12 times per year. Calculate the value of this investment in 10 years' time. Right? Alright, so first thing here, the good thing is, because of this word compound, means we are going to use the compound interest formula. That word compounded there, it's a clue that we're supposed to use the compound interest formula. Right? So our P is 8,000 rand. Our A is unknown, that's the one we're going to calculate. And the time period, now, is going to be 10 years times the compounding period, which is what? Monthly. Now, in a year, how many months are there? 12. So this will be times 12, which is 120. Please remember, N is not the number of years. It's the time period. That is how many times the interest is going to be calculated. 120 times. Then I now. That interest there, it's 8% per year. But the interest is calculated monthly. So we need to know how much interest is going to be calculated per month. So that interest, right, we have to divide that one by what? By 12. Now in my case, I prefer to convert that to a decimal, 0.08 over what? 12. Okay? Remember, 8% is the same as 8 over 100, 0.08. Okay? This is not the only way. Right? Some of you go for tuition. This can also be written as 8 over 100 times what? Over 100.
Times 12.
Times what?
12. 100.
It's 12. So it is what? Alright, let's do it this way. Remember, it's 8% per annum, right? But how many times is the interest going to be calculated? 100 times. It's going to be 120 times. So how else can you write this?
The 8 over 10 times 1.2.
Listen, how else can you write it? In my case, when I teach, I prefer to do it this way.
Yes. This way only.
Right? So I think from now on, let's not do it another way. I don't want. The main reason is because if you make a silly mistake, if you make one silly mistake in terms of the conversion, you will never get the answer correct. Right?
Yes.
Yeah, but I was asking you now. Okay, wait. Okay, let's think here. If it's 8% per annum, right? But the interest is going to be compounded how many times?
12.
No.
You say 8 over 100
No. Yeah, it's 8/20.
times what?
No,
It's not 20.
Times 12.
It's 8/20.
Alright,
Yes.
improve with the calculator.
No.
If you convert
Oh,
this
yeah,
to a
8/20.
decimal, is it going to be equivalent to
No.
that?
No.
So this is 8 over what?
20.
Ah.
Yes. Yes.
No, it's wrong. Okay, look. This way. If I multiply, can I have your attention? If I multiply the numerator by 100, what answer do I get? You get what? 8. If I multiply the 12 by 100, what will I get? So it can be as 8 over what?
That's what I said.
Okay. Okay. This is not Alright. So no, right, you can put it as this, but I listen. If you want, you can do that, but I don't like it, so I'm gonna check this out. I prefer to do it this way.
Yeah, simple.
Right, convert the percentage to a decimal, divide it by the compounding period per year. That's it.
So what's this cheaper as that in the curriculum?
Which you can do.
No, in the thing you said, like, we're writing in the formula. What is cheaper as that?
Yeah, I'm gonna write it. Don't worry. So a equals p times 1 plus y raised to the power of n. Please don't forget to write your formula, because you may get a mark for the formula. Right? Then p is 8,000, right? Times 1 plus I, that's 0.08 over 12. Right? Then where there is n, there you put what? 120. Right, so I prefer that you do it this way. You never go wrong. Oh, what do you mean it's wrong?
It was wrong because we didn't get
What do you mean?
It's not wrong.
17,000.
It's the same. It's not wrong.
17,600.
It's not wrong, check. It's the same thing.
Right.
You see, I'm going to financials.
So this will be 17757, comma 122. This is in rand because it's money.
Yes.
Okay, it's money.
So why did you forget to put the all this? That's wrong.
Well, okay, sometimes the teachers will end up giving you a benefit of the doubt. Right? And we want to penalize you. But you need to know that, can I have your attention? Can I have your attention? We are doing financial math. And in this country, the currency is the what?
Right. Once you put it up also. Because this is formula.
Yeah, I put it there.
No,
No,
there.
it's a formula.
Inside.
Yes.
No. When you are substituting, you don't have to put the unit. When you are substituting, you don't have to put the unit. All right. So, yes? Okay. All right. Okay. Remember what I said last time. R is equal to 100 over times what? Times I. For this question here, our R is what? 8. So let's put 8 here. Right? But, there's a but there. Remember, This 8% is per year. Okay? What will be the interest rate per month? This over what? Are you following? Then if you cross multiply, you get 8 equals to 1,200 I. Then you divide by 1,200. And then you get I equal to 8 over 1,200. But in my case, I don't prefer to do this. Right? What you can do to make things easy, you are in metric. You are in what? Metric. You must be able to convert 8% to a decimal. Mentally, without a calculator. What is 8% as a decimal? 0.0 what? 8. This is the interest as a decimal. But it's per year. But we want the interest per what? Per month. So we divide by what? By 12. Basic knowledge of equation, cross multiplying. 12 times 100 I gives you 1,200 I. 1 times 8 gives you 8. And then you solve for I. So that's grade what? 9. 8. Huh? Right. I'm not even supposed to talk about that. Right? Are you following?
Yes.
Alright, then let's move on to the next example. Alright. So you invest 60,000 rand for 15 years. Calculate the future value of your savings if you receive an interest rate of 12% per annum compounded annually. Right? Right? You invest 60,000 rand for 15 years. Calculate the future value of your savings if you receive an interest rate of 12% per annum compounded annually. Now calculate the future value of your investment. Now calculate the future value of your investment at the interest rate being 12% per annum compounded monthly. Which option produces the highest return? Right. So here we are comparing the compounding periods. So let's start with option 1. Option 1 is compounded annually. Right? So first, okay, just allow me to just put my formula. A equals P times 1 plus I raised to the power of n. Right? So P is 60,000. Okay, then we have got 1 plus I. Now in this case, since it's annually, we just put 12%. So we can put 12% here. Right? Remember, your calculator can convert 12% to a decimal, so you can put like that on your calculator. The number of years is what? 15. What answer do you get here?
328,430.
Don't be so quick. 300.
378,000.
Yes. 495. Right? So the total amount in that investment account after 15 years it will be 328,430.95. Then option 2. Right? Now with option 2 now, the interest rate is now 12% per annum compounded monthly. Therefore, okay, since I've written the formula already, I'm not going to repeat it, write it down. Where there is P, I'll put 60,000, right? Where there is I, see I put 12% here. I put 12%. I can write 12% over 8. Sorry, over, it will be 12% over what? Over 12. Okay, because the interest is compounded what? Monthly. So I can write this as 12% over 12. But in my case, I don't like that. right?
0.12.
Alright, 0.12 over 12. All raised to the power of, now, your n here, 15 times 12. 15 times 12.
118.
That will give you what? 180. Right? Then what's your A?
359,748,
359,
708,
comma
12.
12. Alright, I just want to remind you that here you could have written 12% over 12. It's two the same. Well, the calculator can convert the 12% to the decimal. But I'm doing it manually in my head. But where I put 0.12, you can put what? 12%. But the danger is when you put that 12, if you forgot to put the percent on your calculator, okay. That's why I prefer to convert to a decimal. Because I know that I won't stress about punching the percentage sign. Are you following? Okay. So which option is the best option? So option 2 says which option produced the highest return? Option 2 produced. This is the one that I would prefer if I'm investing money. Okay, I would want to get more interest.
So, why is it so like little difference between the two of these? The options is compounded, no? Should it be like sometimes more?
No.
Why?
Using compounded.
Okay. It's not like this amount is going to be like 1/12 of that option. You see here, we have got two things. The N is affected. Also, the interest rates are affected. Right? Now, this is an exponential function. Right? I hope you know that this number here, if you add it to 1, the resulting answer will be close to 1. Do you agree with me? Do you agree with me? No, but you agree. That 0.12 over 12 plus 1 is 1.1. See, it's a very small one. It's very close to 1. In the end, it won't make a very big difference in terms of the two, but in terms of money, this is a big difference. That's like 30, almost like 30,000 school fees. Imagine 30,000. All right. Okay, I still have got 15 minutes. Let's not talk about the timeline. All right. So this question says 100,000 is invested for 5 years. So we have got our 100,000 there. Okay. 100,000 is invested for 5 years at an interest rate of 16% per annum, compounded quarterly. Right? Thereafter, the accumulated amount is reinvested for a further 6 years. Okay? So the accumulated amount is reinvested for a further 6 years, right? At an interest rate of 15% annum compounded semi-annually. Right? So we have two interest rates that are different. We also have two compounding periods that are different. So calculate the value of the investment at the end of the 11-year period. Right. Now this question, we may need to draw what's called a timeline to illustrate what's happening because of a change in interest rates. Right? The interest rate has changed, the compounding period has also changed. Because of that, we need to have a better picture of what's going on. So, draw like a number line. A timeline is like a number line. Right? At the beginning here, where a person deposits the money after signing the paperwork, we call this T naught. Okay, that's what? T naught. At this point, the person deposits 100,000. Right? Are you following? Yes. Deposits what? 100,000. Now, for the first 5 years, the interest is 16% uncompounded quarterly. Right? Now, here, I would just want you to be aware that I'm going to divide my timeline into a total of 11 years. Then I'm going to take into account the compounding period. So from T naught up to T11. Right? Then I'm going to approximate that maybe here I can call this one T5, where the subscripts represent the number of years. Right? The subscripts represent the what? Number of years. Now, the first 5 years, I need to know what is my end here. By saying n, I'm referring to the time period. Right? So it's 5 years times 4. Times what? 4. Which will be 20. Right? So my n is going to be 20 for the first what? 5 years. Then the remainder 6 years, right? It will be 6 years times 2, because the interest is compounded 2 times per year. Alright? Are you following? Furthermore, I need to take into account my interest rate. So, the first 5 years, my interest rate, right? My I is going to be equal to, it's 16% uncompounded quarterly, so I can write this as 0.16 over what? 4. Right? Then the remainder of the years is going to be, I is going to be equal to 15%, which is 0.15 over 2, where the interest is calculated semi-annually. Right? So this is a timeline. The reason why you need a timeline to do some of the financial maths questions, because they will be complex. Any question which involves 2 interest rates, at least 2 interest rates, or at least 2 deposits or 2 withdrawals requires a timeline to avoid making unnecessary silly mistakes. Right? Now, I'm going to show you something very important. There are 2 methods of carrying on here. Right? The easiest method is to say, we know that our formula for compound interest is A equals P times 1 plus I raised to the power of n. Now, do you agree with me that after 5 years, whatever amount is accumulated here, that amount is going to be invested again, they need to accumulate interest from this on. Yes. So, the A value for the first 5 years becomes the P for the last 6 years. Therefore, I can write one long formula as 100,000 times 1 plus this interest, so that is 0.16 over 4 raised to the power of 20. This is my P now for the last what? 6 years. Then I'll multiply this by 1 plus 0.15 over 2 raised to the power of 12. Okay? This is the shortest way. Another way would be to do it separately. You calculate the amount for the first 5 years, then you get a total. Then you plug in that total into the compound interest formula. But that will take you a little bit long. So this will be a shorter way. What answer do you get? You have to be a guru of the calculator here. Because if you don't know how to use a calculator properly, you can get an incorrect answer.
521,877.
521
877.
2.24.
Yeah.
So you end up having 521,877 and 24 cents. Okay. So that's after 11 years.